So the most likely pattern that's going to take place this summer is a La Nina pattern. And what that means is that the central United States should see temperatures above average based on historical data. I pretty much took all the La Nina summers and put it in a climate division plot and measured the temperature anomalies compared to the long-term average between 1991 and 2020. And this is what the anomalies look like. We see warmer than average temperatures right over the central United States, around average temperatures right up along the Atlantic coast, while right up along the Pacific coast, and even a little bit further eastward than that, we do see cooler than average temperatures. So this should give us a really good indication of what type of temperatures we're going to see this summer throughout the United States. So definitely make sure to take this into consideration. It isn't always the case. We need to take a look at other factors that could maybe manipulate the anomalies, because that's still a possibility, and not every one of these La Nina years are the same. There are certainly differences, despite the fact that they all have a commonality. There are differences when it comes to the factors in each year outside of a La Nina, so we need to take this with a grain of salt, but more likely than not, it should be warmer in the central United States and a little bit cooler than average right up along the west coast and around average along the east coast. So here's how it looks when it comes to precipitation anomalies, and as expected, the central United States experiences a little bit less rainfall than usual, which would make sense because for the temperature to get that warm during the summer like it usually does in the La Nina, it's going to need a lot of sunny days, and it's going to need a lot of sunshine, not rainy days that would prevent the short wave radiation from the sun from really radiating down and heating up the temperature. It's going to need a lot more sunny days, and it definitely makes sense that it's drier than normal right over the Midwest states. And we also see this anomaly extend a little bit further eastward as well, but to a lesser extent. So I do believe that even a small factor could outweigh the typical precipitation anomaly we see during La Nina years. Let's say if we see warmer than average sea surface temperatures, that could bring a little bit more humidity that would completely outweigh the small anomaly, the small deficit we typically see when it comes to precipitation anomalies right up along the Atlantic coast. And I do believe that will be the case with the factors I'm going to show you guys in just a second that relate to the sea surface temperatures as well as what the computer models are stating. So I do believe that the drier than average conditions should focus in more on the Midwest. And what's interesting as well is that during La Nina years, it's a lot drier than normal right over Florida, which is certainly surprised me because typically during a La Nina we see the hurricane season a lot more active, and as we know, Florida is pretty much the epicenter of where most tropical cyclones make landfall in the United States. Well, I shouldn't say most, but at least compared to the other states, it does receive the most tropical cyclones. So it does surprise me that during La Nina years, summers, it is drier than normal right over Florida. So we definitely need to take that in consideration as well, despite the fact that this hurricane season could become historic, which I'll update you guys in a more later video in the near future, possibly tomorrow, who knows. Let's see what video idea comes up for tomorrow, because it could go all over the place, but I'll certainly update you guys when it comes to hurricane season. But point is, Florida during La Ninas typically sees drier than normal conditions, so take that into consideration. And then for the West Coast, it's either a little bit drier or it's either around average when it comes to precipitation or slightly above average. As you know, along the West Coast, most summers, whether it's a La Nina, an El Nino, or a neutral phase, it's pretty much it's hard to get a huge deficit when it comes to precipitation or a huge surplus when it comes to precipitation, because during the summer it's pretty much dry year round, and any rain events, whether the phase is very rare right up along the West Coast thanks to a strong ridge that's centered right over the West Coast during the summer. But during La Nina years, it is slightly more likely to receive at least some precipitation. I imagine that over Arizona, the monsoon season is a little bit more active during La Nina years, so definitely keep that in mind. But again, the precipitation anomaly, it's at its lowest scale as it could be, with that's just outside the range of pretty much zero, of a zero anomaly. So So there easily could be a factor that could outweigh this slight anomaly we see during La Nina years for the western portion of the U.S. Of course, another thing we need to consider when making our summer forecast for the United States is a hurricane season, because hurricane landfalls are quite prominent in the United States each and every summer, especially in the southeast. And typically during La Nina, we see less wind shear right over the Atlantic, which means more hurricane activity, especially right over the Caribbean and the Gulf of Mexico, which could bring a little bit more moisture than usual right up along the southeast coast, where you're bound to experience more hurricanes and tropical cyclones in general during La Nina years. Another key thing we need to take a look at is the drought monitor over the United States, and we clearly see that right now the Midwest is under somewhat of a moderate to a severe drought in certain areas like Iowa and pretty much right up along the northern Mississippi River Valley as well as the northern Missouri River Valley, and we even see drought conditions right over New Mexico. Okay, let me go back just one second. And like I've been repeating in a lot of my previous forecast videos, whether the season, whichever season it is, we like you probably know, when you're under a drought, it's very difficult for that to go away within a quick time period, as it takes time. It really because for a drought to exist in the first place, there needs to be a pretty strong amount of ridging that would stay long enough for the drought to exist. And that means that it's fairly since it's been there for so long, it's very difficult to get rid of at this point. It still could go away by the time we approach the summer. We still have a couple months left, but typically during a drought, it's likely going to stay this way at least for the next few months, and at the very least for the early summer, because during a drought the soil is very dry, so there isn't a lot of water vapor. The atmosphere could evaporate because there's just a lack of water right over a lot of these areas, which is why a drought is so difficult to get rid of. And typically during a drought as well, it's good to point out that it's typically warmer than normal, not only because during a drought, of course, you see more sunny days, but it's due to the fact that dry soil heats up a lot faster than moist soil, so you should expect the temperatures to be warmer than average as well right over the Midwest, as well as portions of the Rocky Mountains this summer. And as for the East Coast, you guys you see that we aren't in a drought at all, and that makes me believe that all the moisture that would typically go right over the Midwest during the summer will shift more towards the East Coast, because with how much sinking air there will be right up along the Midwest thanks to this drought, there needs to be an equal amount of rising air to coincide with the strong amount of sinking air we're seeing. And it's more likely, and the rising air is of course more likely to occur just outside the strong amount of ridging that would be associated with drought, which means that these areas, I'll say, are more likely to receive more moisture as a result of the amount of ridging that's going on here, because it would steer a lot of that convergent energy right over the East Coast for a lot more rising air to occur and thunderstorm activity. Another thing we need to take a look at is the NMME climatology model, which pretty much is a combination of multiple different reliable climatology models into one, which gives us a pretty, at least the best, the most precise forecast model, because it combines multiple different reliable models into one. It could have some issues because, of course, some of the more reliable models are more extreme than others, so you could have an average that's definitely a little bit inaccurate because of some of the extremes we see in some of the most reliable computer models. But since it's combining at least a good amount of the reliable ones, it's more likely to be at least somewhere around the ballpark when it comes to its forecast. And based on what we're seeing with the MME model right now, it's expected to be warmer than average pretty much throughout the United States, with an emphasis more on the Midwest, which does make sense considering that the Midwest is not only in a drought, but typically during La Nina summers, the heat really focuses in right over the central portion of the U.S., with the East Coast maybe experiencing closer to average temperatures, and the West Coast it's typically slightly cooler than average during La Nina summers, which makes sense why the significance of the warm air isn't as the magnitude isn't as high right up along the west coast, which means that it's likely going to be at least somewhere close to average or cooler than average right up along the west coast, while the central United States, it should be much warmer than average. And for the east coast, it could really go either way, but I'm leaning towards slightly below average temperatures, thanks to the fact that it's likely going to be a little bit more moist than average, as the climatology model really indicates that as well, where the NMME model also forecasts a higher amount of precipitation right up along the east coast this summer, so that will contribute likely to the temperatures being cooler than average as well. And thanks to the amount of hurricanes expected this hurricane season, we should expect a little bit more rain right up along the east coast, where the Atlantic will be very active when it comes to tropical cyclone development. And then for the rest of the United States, the climatology model is expecting it to be slightly drier than normal right over the northern Midwest and portions of the Four Corner states, but I do believe the extent will be a little bit stronger than that, considering the fact that we're in a drought, and that's what typically happens during La Nina summers. Another thing that's good to take a look at is the sea surf temperatures right over the Atlantic and the Pacific. And as you can see, the sea surf temperatures are concerningly warm throughout the Atlantic, which means that the hurricane season could be hyperactive. We're bound to experience more tropical cyclones, but not only that, with warmer than average sea surf temperatures right over the Gulf of Mexico and the southeastern Atlantic, we're bound to see just more regular summertime thunderstorm activity that develops just out of the temperature just being so warm, and the which allows the air molecules to move a lot faster to hold a lot more water vapor. So we should see a lot of regular summertime thunderstorms even when a low pressure system, or at least a potent low pressure system, isn't right over the area, which makes me believe that southeast, especially the Gulf Coast, will experience more moist than average conditions this summer, due to the fact that you're bound to experience more summertime thunderstorms thanks to the warmer sea surface temperatures and warmer temperatures in general that will induce, as well as the fact that you will see more tropical cyclones. And for the west coast, what's interesting is that the Pacific right now is experiencing sea surface temperatures warmer than average, and that could mean that the May gray and June gloom you typically see during the early summer won't be as potent, because the air temperature and the sea surface temperatures difference won't be as strong, which means that there's less likely to be fog developing when we see the ocean temperature as well as the air temperature a little bit closer when it comes to temperature. So that could mean that at least for the early summer, it should be a little bit warmer. But considering the fact that during La Nina summers, it's simply cooler than average in general, I still do expect it to be cooler than average right up along the Pacific coast. So here's my complete summer forecast for the United States. It should be more rainy and humid right up along the northeast coast, thanks to the fact that since this drought is going on, we're going to see more of that convergent energy move towards the east coast, which means that we're going to see a lot more humidity, more thunder shower activity developing, as well as the fact that the sea surface temperatures are warmer than average. So we should see more regular thunderstorm activity just develop for the northeast as well as the southeast. And of course, the hurricane season will be more active as a result of that. So that should definitely raise the precipitation anomalies all throughout the east coast, no matter where a tropical cyclone makes landfall. And for the Midwest, it should be very hot and very much drier than normal, thanks to the fact that that typically happens during La Nina summers. And then right up along the west coast, it should be a little bit cooler, but mainly dry like it usually is during the summertime. As during La Nina summers, it's very typical for the temperatures to be cooler than average in general. So that's my summer 2024 forecast. If you want even more in detail forecast, make sure to comment your location or area down below, and I'll make sure to give you guys a more in detail forecast when it comes to what type of conditions you should expect this summer. But that's it for now, guys, and I thank you guys for watching.